In this section, we're going to examine the technique of differentiating implicitly. Listed here are some common terms that we might see in an equation. And the list shows what they would be replaced with after differentiating implicitly. Step 1 will be to differentiate all the terms in the equation, where y variables are assumed to be functions which are not necessarily constants. For this reason, we have to apply the chain rule accordingly whenever taking a derivative of a function involving y. Now, once we have all the differentiation done, we can simplify and solve for dy over dx. I'll show how it works with these examples. Now, in the past, we differentiated explicitly, which means when a formula here is solved for y, we could do dy over dx and then find the derivative of x. And then it would have been done explicitly. To differentiate implicitly, though, what you do is you leave them in the positions they're in. So you start with y equals x, leave y and x in the positions they're in, and turn them into differentials. Now we have a relationship between the differentials, and we can divide both sides by dx if we wish to reveal that dy over dx is 1. Let's try this next one. Two y equals 3x. We could replace it with 2 dy equals 3 dx. And then we could divide both sides by dx. We'll get 2 dy dx. 2 dy dx equals 3. Now, oftentimes, when we're doing implicit differentiation, we may skip right to this step. And the way we do that is just by replacing y with y prime, which is dy over dx. And replace x with just a simple 1. The last step is to get dy over dx alone, and here we would divide by 2 to reveal that dy over dx is 3/2. The next one's got more terms. In this problem, I'm going to use the guide above to replace the different terms with what it says they should be replaced with in implicit differentiation. So 8y will actually become 8 times dy over dx. The derivative of a constant, though, is just 0. Now, when we do the derivative of negative 2x, according to the guide above, x gets replaced with 1, so this will just become a negative 2. And then the derivative of negative 6 is 0. We now want to simplify. And we'll divide by 8. And there's our answer. The next problem, though, involves y squared. And that's a little bit trickier to deal with. We're going to have to use the chain rule, which means we find the derivative of the y squared. And that would be 2y. But we can't stop there. We also have to multiply by the derivative of the chain, which is the y here. The derivative of negative 4x will be negative 4. And there we don't have to put dx over dx because it would just be 1. Here I'll do 10x, and x prime is just 1 again, and the derivative of 4 is 0. So when we have terms involving x, they get differentiated as normal. But when we have terms involving y, that's the tricky part. That's where we have to use chain rule. All right, now we'll solve here we can see that the actual original function y is part of its derivative formula. So that's an interesting situation that we'll come to explore in future videos. Try the next two for yourself, and then I'll give my answers. Okay, for this one, we're going to differentiate 9y. So we're going to get 9 dy over dx. Then we'll get plus 5. And yeah, just the difference between y and x is that when you differentiate y with respect to x, you have to put that y prime there. But when you differentiate x with respect to x, it's just 1. So you don't have to put anything there. Here we'll get negative 4x, typical derivative of that. And we'll get plus 12y, but we have to put dy dx. All right, so hopefully you got that far with it. The next thing to do is to actually solve for dy dx, so we're going to have to get the like terms on one side. So I'm going to move this part over. And I'll move the 5 to the other side. We now want to factor out the common dy dx. So pull that out front. Now that we have a single dy dx, we can solve. And that's our final answer here. All right, for this last one, I'll do it on a new page. All right, so with this one, we see that we're going to have to use product rule in a couple places. Derivative of x cubed is going to be 3x squared. So that's no problem. But here, we're going to have two terms. First, I'll leave the negative 2x squared alone. And I'll take the derivative of the y. Now I could write dy over dx. However, when these equations get pretty big, We may wish to just use y prime in place of dy over dx. Just a little more concise. Then what we'll do next is we'll take the derivative of that first part, making negative 4x, and then we'll leave the y alone. That's product rule. I'll do the same thing with this other term. Alright, so first I'll leave the 4x alone, and then I'm going to multiply by the derivative of y squared. But that'll be 2y, y prime. Now I'll take the derivative of the 4x and leave the y squared alone. And set it equal to 0 because the derivative of 20 is 0. Alright, now our goal is going to be to get the y primes together. So let's see if we can move both those y prime terms to the left. And I'll move the other terms to the right. I want to factor out the y prime. And we'll leave this behind. And we'll divide. There's our answer.